Alright, before we start going over the review, let's look at the formulas that you're going to be given the day of your test. These two formulas right here will help us find term numbers. And the top one is your arithmetic one, meaning we're adding something over and over. And the bottom one is your geometric, means we're multiplying by the same number over and over. These other three formulas will help me find the sum. This first one is a sum for arithmetic. The second one is a sum of a geometric. And the last one over here is a sum of a geometric that's infinite, meaning it doesn't stop. Alright, so it says state whether the given sequence is arithmetic, geometric, or neither. Find the 17th term of the sequence. We have to do two things for each of these problems. The first thing I need to do to decide is if it's arithmetic, is am I adding, subtracting, or multiplying to get to the next number. So I always try to see if I'm adding first. So 1 plus 3 is 4, and 4 plus 3 is 7, and 7 plus 3 is 10. So to get each term, I'm adding 3 every time. So this is arithmetic. Because I'm adding 3 every time, the common difference is 3. So because it's arithmetic, I'm going to use the top equation to find the 17th term. So T17 equals the first term, which is 1, plus, it says N. N is 17, because it's the 17th term, minus 1 times D. And my D is 3. So from there, you're simply going to go to your calculator and type it in. So 1 plus parentheses, 17 minus 1 times 3. So my 17th term is 49. Okay, let's go look at the next one. Again, I'm going to start with, did I add or subtract? So 8 take away 4 would give me 4. But 4 minus 4 is not 2, so it's not arithmetic. So now I'm going to see if it's geometric. To see if it's geometric, I'm going to take these first two terms and divide them. I'm going to always divide the second term by the first term and see if that would be my R. So the second term is 4, divided by 8 is 0.5. So if I can multiply each of these terms by 0.5 and get the next one, it means it's geometric. So 8 times 0.5 is 4. And then I do 4 times 0.5 and I get 2. And then I do 2 times 0.5 and I get 1. So I know it's geometric. And I was multiplying each term by 0.5, or 1/2, whichever one you like. Again, they want me to find the 17th term, but this time, because it's geometric, I'm using the second equation. And it says to take T1, which is your first term, times R, which is 0.5, and they want me to raise it to the n minus 1. So we're going to raise it to the 17 minus 1. From there, we just go to our calculator. So we're going to have 8 times 0.5 raised 1 of 17 minus 1 is 16. So I'm just going to type in 16. So the answer is 1.22 times 10 to the negative 4. So 1.22 times 10 to the negative 4. I also know because it's to the negative that I'm going to move my decimal 4 places to the left. So that would be 0.000122. So I could write my answer either way, scientific notation, or I could simply move my decimal place 4 places to the left. So 1, 2, 3, 4 would be 3 zeros up front, the 1, then the 2, 2. Okay, why don't you go try 3, 4, and 5, pause the video, and then come back and check your work. Okay, so hopefully you paused the video and you've come back to check. Number 3 is arithmetic. And my common difference is negative 4, because I'm subtracting 4 every single time. So to find the 17th term, I'm going to use my arithmetic formula. And it says to take my first term, which is 30, plus n minus 1, my n is 17, times negative 4. You're going to go type it in your calculator, and you're going to get negative 34. Number 4 was arithmetic. And my common difference was positive 4, because I'm adding 4 every single time. So the 17th term equals the first term plus 17 minus 1 times 4. When you plug that in your calculator, we get 81. Number 5 is geometric. When I divided the second term by the first term, we get r as 1.5 or 3 over 2, whichever one you liked. So then to find the 17th term, we're going to use the geometric formula this time. My first term is 8 times 1.5 to the 17 minus 1. And when I type that in my calculator, I got 5254.73. I just rounded it. Okay, so when you're doing 1 through 5, you have to decide if it's arithmetic or geometric first. If it's arithmetic, you're going to plug into the top equation and get an answer. And if it's geometric, you're going to plug into the bottom equation and get your answer. So let's go look at 6 and 7. It says use the indicated formula for the general term, the nth term of an arithmetic sequence to find the indicated term. So for number 6, they tell me the first term is 15. They tell me my common difference is -4, and they want me to find the 15th term. Because it's arithmetic, I know I'm using this formula right here. So it says that they want me to find the 15th term. And my formula says to write down the first term, well, they gave it to me, plus n minus 1. The 15, that's your n, so 15 minus 1, and they told me my common difference was -4. From there, we're going to type it in the calculator just like we were earlier. So 15 plus 15 minus 1 times -4. And out pops -41. Okay, so I want you to pause the video and go try number 7 and then come back and check it. It's the exact same stuff. Okay, so on number 7, they want me to find the 15th term again. So T15 equals, I already know it's arithmetic. They told me in the directions. So I'm using this formula right here. It says to write down my first term, which is 15, plus n minus 1. My n is this little number here, which is 15, times my common difference of 8. When you type that in your calculator, you should get 127. Number 8 and 9 is the exact same technique, except this time they're telling me that it's a geometric sequence. So they're telling me it's geometric, they're giving me my first term, they're giving me my r, and again, they're asking me to find the 15th term. So my geometric formula says that we're going to write down the first term times the r to the n minus 1. So my first term here is 12 times my r of 4 to the 15 minus 1. I'm going to type that in my calculator. 12 times my r raised 15 minus 1 is 14. So it's 3, 2, 2. 3, 2, 2. 1, 2, 2. 1, 2, 2. 5, 4, 7, 2. There we go. Okay, so just a matter of knowing which formula to pick and typing it in your calculator. So again, pause the video, go try number 9, come back and check your work. So number 9, they want me to find the 15th term again. Remember my formula says I start with my first term, which is 24, times my r, which is 1/2, raised to the n minus 1. 15 is my n, so it's 15 minus 1. So again, we go to our calculator, and I'm going to go type in 24 times 1/2 raised 15 minus 1 is 14. So 0.0014648. Let's see, 0.0014648,438. And I'm not sure where Ms. Puckett's going to round them on the test, so just look what's in the calculator, look at your answer choices, and round appropriately. Okay, so what y'all normally are having trouble with on your quizzes are problems like 10 and 11. Anytime they ask you for how many, and you're going to see a couple of these on the test, you're solving for n. Solve for n. And by n, I'm talking about these equations right here. If it's arithmetic, you're solving for this n. If it's geometric, then you're solving this one up here. So on number 10, it says, how many 4-digit numbers are multiples of 6? So your very first 4-digit number, 1000, divided by 6. That does not divide evenly. So I'm going to try the next one, 1001, divided by 6. Oops, Forgot to hit divided by 6. That doesn't work either. So 1002 divided by 6. Oh, there it is. So my very first 4-digit number that I can divide by 6 is 1002. And that's how I start my sequence. Okay, because they're multiples of 6, to get the next one, I just add 6. So 1002 plus 6. Let's go make sure. Hey, yeah, that does. So 1008. Dot, dot, dot. I also have to find the last 4-digit number. So 9,999 divided by 6. That one doesn't work. So a couple ways to do it. You can just keep working backwards if you want. 9,998 divided by 6. 9,997 divided by 6. 9,996 divided by 6. And there it is. So my last 4-digit number I can divide by 6 is 9,996. 9,996. Okay, again, we're solving for n, and we're using this equation right here. Tn equals T1 plus n minus 1 times d. Tn represents your last term when you're solving a problem like this. So 9,996. T1 represents our first term, which was 1002. We're solving for n, and my common difference, what was I adding to get to the next term? It was 6. For here, it's an Algebra 1 problem, and you can do this several different ways. I like to go ahead and move the 1002 over, so I go 9,996 minus 1002, and I get 8,994 equals 6 times n minus 1. Some of y'all like to go ahead and distribute here. I prefer to go ahead and divide. So I take 8,994 and divide it by 6. And I get 1,499 equals n minus 1. So to get n, I simply add 1. And I get 1,500. So there are 1,500 terms that are divisible by 6 that are 4-digit numbers. All right, number 3 is going to work the exact same way, except we're doing 3-digit numbers divisible by 7. So what I want you to do is pause the video, see if you can figure out the sequence, and then solve for n. Okay, so hopefully you've paused the video by now, and you've tried several 3-digit numbers, and the first 3-digit number you can divide by 7 is 105. So 105 divided by 7. So to get the next one, I'm going to add 7 more. And I get 112, dot, dot, dot. I need to find the last 3-digit number. So your last 3-digit number, period, is 999. That does not divide by 7 evenly. And then we do 998, 997, 996, 995, and then we're going to do 994. And that's the last one that works, 994. Okay, so again, we're going to use this formula right here, same one. Tn represents the last term, so 994 equals the first term, 105, plus n minus 1 times d. This time my d is 7. Okay, again, several different ways to solve this. You could distribute and combine like terms if you wanted. I like to go ahead and move the 105 over. So I take my 994 and I subtract my 105. And I get 889 equals 7 times n minus 1. You could distribute, but I prefer to go ahead and divide by 7. 889 divided by 7. And we get 127 equals n minus 1. And then I add 1 to both sides. And I get 128. There are 128 terms. Okay. Number 12 and 13 are recursively defined, and they want me to list the first 4 terms of the sequence. So on number 12, they give me the first term is equal to 5. I have to go find the second, the third, and the fourth. And I have to use this definition right here. Remember, n minus 1 represents the term above. So to find T2, I take the term above and add 3. So 5 plus 3, and that gives me 8. To find T3, I take the term above, which is 8, and add 3, which gives me 11. And one last time, to find T4, I take the term above, which is 11, and I add 3, and we get 14. So my terms are 5, 8, 11, and 14. So again, like we've been doing, go ahead and pause the video, go try number 13, and then come back and check your work. So on number 13, T1 is 2. To find T2, I take the term above and I subtract 3. So 2 take away 3 is negative 1. To find T3, I take the term above, which was negative 1, and I subtract 3, and I get negative 4. And I do it one more time. To get the fourth term, I take the term above and subtract 3, and I get negative 7. So my answers are 2, negative 1, negative 4, and negative 7. On number 14 and 15, they are telling me it's an arithmetic series, and they want me to find the specified sum. So this time, I'm going to use my sum equations, and because it's arithmetic, I'm using this one right here. So the n represents the number of terms in the series, T1 represents the first term, Tn represents the last term, and then I divide by 2. Okay, so on 14, they want me to find the sum of the first 10 terms. So right there, that's your n. So my formula says to find the sum of the first 10 terms, the first thing I write down is my n. My n is the 10. Parentheses, your first term. My first term was 3. They told me right here. Plus my 10th term, which is 39, all divided by 2. From there, you just type that in your calculator. So I'm going to type in the top, so 10, parentheses, 3 plus 39, enter, divided by 2. My answer is 210. So the sum of the first 10 terms is 210. Okay, number 15. I already know it's arithmetic because they told me. They gave me the first term, and they gave me the last term. So this is my T1, and this is my Tn. What they did not tell me was my n. So I'm going to have to go find n just like we did up here to these two problems. Okay, so I have to find n first before I can plug into my formula. So remember, to find n, you start off with the last term, and then we write down our first term plus n minus 1 times the d. It looks like I'm adding 4 every time. So we're going to go solve for n. So by now you know how I like to do this. I'm going to say 99 minus 3 first and get, oops, I put plus. Let me try that again. 99 minus 3, and we get 96. So 96 equals 4 times n minus 1. And then I'm going to divide by 4. Again, you could distribute, but I like to go ahead and divide. And we get 24. So I have 24 equals n minus 1. So n equals 25. Okay, so now I have my n, I have my T1, I have my last term, so I can go plug into my formula. So the sum of the first 25 terms, because my n is 25, is 25 times my first term, which was 3, plus my last term, which is 99, all divided by 2. And we're going to put that in our calculator. 25 parentheses, 3 plus 99, enter, divided by 2. 1275. Okay. Number 16 says find the sum of the first 25 terms of the arithmetic sequence 3, 11, 19, 27. So this time they gave me my n, they gave me my first term, but they didn't give me my last term. So I have to go find T25 before I can plug into my formula. So T25 equals, I'm going back up here to this original equation to find the 25th one. So the formula says that you write down your first term, which is 3, plus parentheses n, my n is 25, minus 1 times my d. Well, what am I doing to get from 3 to 11? I'm adding 8, so my d is 8. I'm going to go type that in my calculator, 3 plus 25 minus 1 times 8, and they tell me that my 25th term is 195. Okay, so now I can go plug into this equation, because now I know my n, my first term, my last term. So S 25 equals, my n is 25, my first term is 3, my last term is 195, all divided by 2. So 25 parentheses, 3 plus 195, enter, divided by 2, 2,475. Okay. Alright, so let's take a look at the back of the review. So on the back we've got 2 word problems. In order to do these word problems, the first thing you want to do is just start your series or your sequence, whatever they happen to give you. So for number 17, it says the Value Appliance Stores has radios that can be purchased on a daily installment plan. For a particular type of radio, you pay 15 cents the first day, so 15 cents. And then you pay 30 cents the next day, and then 60 cents the next day, and so on for 14 days. So that's day 1, 2, 3, ... I'm going to do that until I get to 14. And they want to know how much does the radio cost. Well, it looks like I'm adding the cost, so this is going to be a series, and I'm going to want to know how much it adds up to. So it's going to be one of these 2 equations right here. If it's arithmetic, I use the top. If it's geometric, I use the bottom. So how am I getting from 15 to 30 to 60? Well, I'm multiplying by 2, so it's geometric, and my R equals 2. So I'm going to go plug into this equation right here. And it says take your first term, my first term was 15 cents, times 1 minus your R, my R is 2, to the n. We're doing it for 14 days, that's my n, to the 14th, all divided by 1 minus 2. Okay, so we're going to do this in 2 steps. I'm going to type in the top, I'm going to hit enter, and then I'm going to divide by the bottom. Okay, so I've got 15 cents times 1 minus 2 raised to the 14, enter, divided by parentheses 1 minus 2. So it's going to cost $2,457.45. $2,457.45. Okay, number 18. Jake is creating a mosaic piece of artwork. It will have a total of 18 rows. That's my N. The bottom row requires 130 tiles, so that's the first one. Each successive row requires 4 less. So 4 less than 130 would be 126, and then 122, all the way until I get to the 18th row, whatever that number happens to be. And they want to know how many tiles will I need total. Okay, so this is going to be another one of these S equations. I just need to figure out, was this one arithmetic or geometric? Well, this time I'm subtracting 4 over and over, so it's arithmetic, and my common difference is -4. Okay, so to plug into my sum equation for 18 rows, it says that I need the number n, which is 18, so I have that, times the first term, which is 130, plus the last term, I don't know that one yet, all divided by 2. So I need to go find the 18th term. So I also have to go use this equation here. I'm looking for the 18th term. So to find the 18th term, I take the first term plus 18 minus 1 times my common difference of -4. So the 18th term is going to equal the first term plus 18 minus 1 times -4. Let's go find out what that is. So 130 plus 18 minus 1 times -4. So my last row of mosaics is going to have 62 tiles. Now I can figure out how many I have to go buy from the store. So you take your n times your first term plus your last term, then you divide it all by 2. So I need to order 1,728 tiles. I'll probably order a little bit more in case I break one. This is the number that I have to have. Okay, On number 19 and 20, it says find the sum of the given infinite geometric series. Because it says infinite, I know the formula I'm going to use is this one right here. And I'm simply going to plug everything in. So S equals the first term, which is 24, over 1 minus my R. Well, to find R, we divide the second term by the first term, which would give me negative 0.5. So I have minus a negative 0.5. So let's go type that in our calculator. 24 divided by parentheses, 1 minus a negative 0.5. And that's going to tell me my answer is 16. Just remember when you type it in your calculator, this bottom number has to go in parentheses. Number 20 works the exact same way. So S is going to be the first term divided by 1 minus my R. Again, to find R, I'm going to say 3/5 divided by 3. And it's nothing magical, you just go straight to your calculator. So 3/5 divided by 3 equals 0.2. It's a positive 0.2, so I don't have to worry about the double negative. When you type it in, don't forget to put the bottom in parentheses. So 3 divided by 1 minus 0.2. So the answer is 3.75. And make sure you math bracket just in case Ms. Puckett decides to put the improper fractions. They mean the same thing. Just make sure you know that they do and how to math bracket in your calculator. All right, 21 and 22. 21 says write out the sum, do not solve. And a lot of y'all messed up on this on the quiz. When it says write out the sum, they want you to plug the K values in that they tell you to start with and end with. So this particular problem, the first K value I'm going to plug in is 1 plus 2. And then after 1 comes 2 plus 2. And then 3 plus 2. This is my K, and I have to keep doing this until my K gets to 6. Okay? And then 4 plus 2. And then 5 plus 2. And then 6 plus 2. And then from there you need to simplify it. So 1 plus 2 is 3. Plus 4, plus 5, plus 6, plus 7, plus 8, and we're going to stop right there. So when they tell me that they want me to start at 1 and end at 6, they're talking about the K values, 1, 2, 3, 4, 5, and 6. Notice I didn't stop right here. I stopped after plugging in 6, and a lot of y'all were stopping here on the quiz. So we're going to go try it again right here. This time they want me to start where K is 1, but they want me to end at N, which means it goes on forever. Well, obviously I'm not going to make you go on forever, so we're going to do the first 3. So 5 to the 1 plus 2, and then 5 to the 2 plus 2. Remember, these are my K's. And then 5 to the 3 plus 2, dot, 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 5 to the N plus 2. And we're going to go simplify, and we're going to get 5 to the 3rd, plus 5 to the 4th, plus 5 to the 5th, plus 5 to the N plus 2. Okay? You could also, if you wanted to, go one step further and do 5 to the 3rd in your calculator. And I think it tells you 125. So we have 125 plus 625 plus 3,125 plus 5 to the N plus 2. So you're just going to have to look at your answer choices and see where does Ms. Puckett stop. So if she left them like this, you can stop. If you notice that this isn't an answer choice, you need to keep going. Okay. On 23, 24, and 25, they want you to write these using sigma notation. So on 23, what are we doing to get from 4 to 8 to 12 to 16 to 20? We're adding 4 over and over and over. But I told y'all in class, if you're adding 4 over and over and over, you're really doing repeated addition, is really repeated multiplication. So we can see when K is 1, 1 times 4 is 4, 4 times 2 is 8, 4 times 3 is 12. So if I was going to write this in sigma notation, the K started at 1, the K ended at 5, and we're doing 4 times my K's. All right, for 24, We went from 1 to negative 1/2 to positive 1/4 to negative 1/8 to positive 1/16 to negative 32. Anytime your signs are going positive, negative, it's going to be a geometric. So I need to figure out what am I multiplying by. So I can tell that I'm multiplying this by negative 1/2, and if I wasn't sure, I would just go divide the second term by the first term, and negative 1/2 divided by 1 is negative 1/2. And we said that when they're geometric, that means that we have powers going on. So when it's arithmetic, we're going to multiply for sigma notation, but when it's geometric, we're using powers. So negative 1/2 to the 0 is 1, negative 1/2 to the first is negative 1/2, negative 1/2 to the second is 1/4, this will be third, this will be 4, and this will be the fifth. So my sigma notation, k is going from 0 to 5, and we're doing negative 1/2 to the k. All right, last one here. As I was looking at these trying to find a pattern, I saw 5, 6, 7, and they were being squared. So for this one, I said my k starts at 5, and it ended at 15. And all I'm doing is taking each one of these values and squaring it. And again, if you get stuck on this on the test, they're going to be multiple choice. So since they're multiple choice, it's not a really big deal. You just go in and you plug in your k's until you find the one that matches the pattern. Okay, on number 26, they actually want you to go find the sum. So on number 26, if you'll notice, it's the exact same problem we had up here, but it stopped at 4. And they want me to actually go find the sum, so they want me to get my answers and then go add them up. So first I'm going to go plug in a 1 here. So if I plug in a 1, I get 1 plus 2, which would be 3. And now I'm going to go plug in a 2. 2 plus 2 is 4. Now I'm going to go plug in a 3. 3 plus 2 is 5. And now I'm going to go plug in a 4. 4 plus 2 is 6. And I'm going to stop because I have to stop after I plugged in a 4. So I plugged in a 1. I plugged in a 2. I plugged in a 3. I plugged in a 4. And because it said find the sum, not write out the sum, I'm actually going to go add these up. So 3 plus 4 is 7. And 7 plus 5 is 12. And 12 plus 6 is 18. Okay, we're going to do the exact same thing right here, and they want me to go to the 5th term. So we're going to have 5 to the 1 plus 2, so 5 to the 3rd, plus, if I go plug in 2, 5 to the 4th, if I go plug in 3, 5 to the 5th, so that's plugging in 1, 2, 3, plus 5 to the 6th, plus 5 to the 7th. Okay, and I'm going to go make my life easy. I'm just going to go type these right in my calculator. I'm not even going to try to evaluate them any other way. So I'm going to do 5 raised to the 3rd, plus 5 raised to the 4th, plus 5 raised to the 5th. Let's see, that's 1, 2, 3, 4, 5, yeah. Plus 5 raised to the 6th. Oh, I forgot my plus sign. I'll insert that. Plus 5 raised to the 7th. Okay, so my answer is 97,625. 97,625. Okay, the last part of your review is limits. And there were 2 things, or 3 rules I told you. I told you if your R was less than 1 and you were raising it to the n power and you were doing a limit, that it was going to approach 0. And I told you if R was greater than 1 to the n power and you were approaching infinity, that it would go off to infinity, which means it does not exist. So I'm going to do these 2 rules first. And then we talked about Bobo, Botan, Eats, DC. If you're looking at a fraction and you're looking at the exponents, you're looking at the exponents again. And if the exponent is bigger on the bottom, the limit approaches 0. If the exponent is bigger on the top, then it does not exist. It goes off to infinity. If the exponents are the same, you divide the coefficients. So I'm going to use these rules as I do these problems here. You don't have any formulas for this. You just have to know it. Okay, so on number 28, the first thing I'm going to notice is that I have a fraction. So because I have a fraction, I'm doing Bobo Botten eats DC. And the biggest exponent on top is x to the first, and the biggest one on the bottom is also x to the first. Because they're the same, exponents are the same, we divide the coefficients. So 2 divided by 6 is 1/3. This limit will approach 1/3. Number 29, I've got another rational. So my biggest exponent on top is a 2. The biggest exponent on the bottom is a 1. So this time, it's bigger on the top. Bigger on top, it goes off to infinity, which means it does not exist. Number 30, another fraction one. I have a 1 on top, that's my biggest one, a 2 on the bottom. So this time it's bigger on the bottom, so my limit approaches 0. 31, this time I don't have a fraction like these. These aren't rationals. I don't have exponents with letters and stuff. So I've got 0.9999. That's a number less than 1 being raised to the n, or x. As I go off to infinity, it's going to approach 0. 32 is another fraction, and I have an x first on top and an x to the first on the bottom. They're the same, so it's an eats DC. So I divide the coefficients, and we get 2/3. 33, I have an x squared and an x squared. Because they're the same, I divide the coefficients, and we get 8/5. I have an x to the fourth on top and an x to the first on the bottom, so it's bigger on top, so it approaches infinity, which means it does not exist. 0.999999 is a number smaller than 1, so it approaches 0. 1.001 is bigger than 1, so it goes off to infinity, which means the limit does not exist. Okay, I have a rational here. So I have an x to the first over an x to the first, so 1 divided by 1 is 1. X to the first and an x to the first, so 4 divided by 2 is 2. I have an x squared and an x squared, so 3 divided by 8 is 3/8. I have an x to the fourth and an x to the fifth. It's bigger on the bottom. Bigger on the bottom is a Bobo, so it approaches 0. Okay, you have to know this. This is not going to be written on the test. The only thing you're going to get on the test are these formulas right up here at the top, but you have to know how to use them. I hope the review helped. Study, work it a couple times. This is your last test of the grading period. You'll really need this test grade to pull your averages up. Good luck.